Bismillah ar-Rahman ar-Rahim. Welcome to the new lecture of physics. So today we are going to be studying about torque and equilibrium. So before going to be start torque and equilibrium, so we are going to be exchange some parameter like we studied before about linear velocity, linear acceleration, linear displacement, mass, kinetic energy, potential energy, and so on. So very simple way to transfer a linear parameter to angular parameter. Whenever you are seeing a displacement, so in a linear we can represent displacement by x or by s, as you use all or by d as well. So in angular you just see it by theta. So x is equal to r theta. It's angular motion now. So angular displacement. So now if you are going to be transfer a linear velocity to the angular velocity, so just replaced v by omega. This is called omega. So v is equal to omega r. The same definition you studied in a linear, same formula, same definition. It's you study about velocity. So the rate of change of displacement, the rate of change of linear displacement is called velocity. So the same definition will be applied. So you can say the rate of change of angular displacement is called velocity. So it's simple. Just replace linear displacement by angular displacement, just like acceleration. So in a linear acceleration we represent it by a, so in angular we will represent it by alpha. So what was the definition of a linear acceleration? The rate of change of a linear velocity is called linear acceleration. So now we are going to transfer it to angular acceleration. So the definition will be the rate of change of angular velocity. For a linear acceleration was linear velocity. So the rate of change of linear velocity is called a linear acceleration. So the rate of change of angular velocity is called a angular acceleration. So this is the formula which we will be using a numerical analysis. So then coming to inertia, and you know about inertia, energy is a mass. So in a linear we represented by m, and in angular we be represented by I, inertia. So in a kinetic energy, again you know about a kinetic energy, half mv square. So you know about m in angular we will replace m by I and v by omega. So I omega square. Then force. So in a linear parameter we represent force by F, and in angular we represent by torque. So what is torque? We will study later on. So then coming to Newton law, Newton's second law is F is equal to ma. You know about m is the inertia, a is the alpha, so torque is equal to I alpha, and so on. So this is just some parameter which we can be transferred from linear to angular, and whatever you are going to be see in your physics, you just replace the linear by angular. So you will be get the angular formula. So now we are coming to start about a torque. So what is torque? So one thing which is very simple, or we also can say the mathematical definition of a torque. So just keep in mind the cross product of a force and a momentum. What is momentum? Let's see, this is your rod, okay, this is your rod, and you are applying a force on this position. So this is the center point. So from this point to this point, this is a momentum, this is a distance. So when you are applying a force on a rod, so maybe this rod going to be rotate, maybe it's not going to be rotate. If it rotates, it means there is a torque. If it's not rotate, mean the torque is going to be zero. So that's why we are saying that the cross product of a force and a momentum. Because one thing more, keep in mind, whenever you have a force and momentum, so always you are going to take a perpendicular component of a vector. Why we are going to be taking a perpendicular component? Because you know about in a cross product we are using a sine theta. So when both of the vector force and momentum are parallel, the theta is going to be 0 and sine 0 is 0, so it means there is no torque. If force and momentum is going to be perpendicular, which is making an angle of 90. So sine 90 is always equal to 1. So when sine 90 is equal to 1, so it means there is a torque. So coming to the definition, a torque is a force x distance rate cause a rotation. It tells how effective our force is at twisting or rotating an object. It's a little bit of a difficult definition, but you can be said the cross product of a force and a momentum is called torque. Or you can say that when a force is applied on a body and a body is going to be rotate, that's called torque. It's another definition. So mathematically we can define that torque is equal to torque represented by T is equal to or is a momentum and a force is your perpendicular force. So when you have a perpendicular force, if you remind your scalar and vector lecture, so I told you there that when we have a perpendicular component and a cross product, so we are going to be use a sine theta. Why we are going to be use? If you can see here, the theta is going to be make here. So in the front of a theta we have a perpendicular component, so then you can find that this component, then you will have a f sine theta, if you remember the scalar and a vector lectures. So T is equal to R F perpendicular and a perpendicular used by sine theta. So one thing keep in mind that torque is a vector quantity. So when two vectors are going to be multiplied and there will be the result will be the third vector. So we have some unit vector as well. So how it can be happen that you have a momentum r and you have a force. So when you are applying a force on a momentum and the object is going to be rotate, so the third vector will be a torque. Okay, so later on we will see. So one thing, unit of a torque is newton meter, because the unit of a force is newton, unit of force is newton, and the unit of momentum or a distance is meter, so that's called newton meter. We have some conventional aspect about a torque, that whenever you have a counterclockwise torque, or we can also say that anti-clockwise rotation or a torque. So counterclockwise or anti-clockwise rotation is always going to be positive, and a clockwise rotation is always going to be negative. It's just convention, there's no concept behind that. So just keep in mind about it. So now we have a two-way to compute the torque. So what does it mean? Let's see, we have a momentum. This is your momentum, and you are applying a force on this angle. So this is your theta. So now we need to find a component of a force which is try to rotate a momentum, or which is try to rotate a object. Okay. So this is your theta. So draw the component of a force. So draw the perpendicular component on a momentum. So in the front of theta we have perpendicular component. So when you are going to find a perpendicular component, then you will have a f sine theta. F sine theta. So that's why, so torque is equal to Rf sine theta. R is your momentum, and the component of a force which is try to rotate the object, which is F sine theta. So that's why we are using F sine theta. It's so simple. You guys study about it in a scalar and vector. So just try to find the component of a vector which is helping to rotate an object, like, so that's called torque. So this is the way. Another way is decompose f into component parallel and perpendicular. So the perpendicular component of force is f sine. You can also be used like this. This is a perpendicular sign. Okay. So f rotation is a clockwise. So torque is negative. I told you before. And f rotation is counterclockwise torque. So the counterclockwise torque or anti-clockwise torque is positive. Okay. So it's so simple thing. So now coming to equilibrium. So one thing keep in mind that torque is related to equilibrium. If there is no force, or if you can say that the sum of all the forces or the net of all the forces is equal to be zero, and the net of all the torque is going to be zero, so we can say that the object is in equilibrium. What does mean by equilibrium now? So the equilibrium mean that the object is going to be in a rest form. Like you have a book on the table, so this book will be on the table. Force is applied, torque is applied, but all the forces, the sum of all the forces is going to be zero, and the sum of all the torque is going to be zero. So you know about the equilibrium now. What is equilibrium? The equilibrium is that your object is going to be in a rest form. Okay. So for equilibrium, keep in mind we have a two conditions. So condition for equilibrium. So two conditions always need to be satisfied for an object which is going to be in a equilibrium. So the first condition is, this is the first condition, keep in mind that the sum of all the forces is going to be applied on an object is going to be zero. That the sum of all of, maybe you have of two forces, three forces, 4, 5, 6, and 8, whatever, all, so the sum of all the forces is going to be zero. So this is the first condition. So the sum of all the forces is going to be zero, so you can say that it will be equilibrium. But there's another condition as well. So second condition is that the sum of all the torque, the sum of all the torque is going to be zero. Okay. So when the sum of all the torque which is applying on the object is going to be zero, so it means the object is going to be in equilibrium. So for each and every object which is going to be in equilibrium, they need to be satisfied both the condition. If the object is going to be satisfied one condition, so let's see, we can say that the sum of all the forces is going to be zero, but the sum of all the torque is not going to be zero. It means the object is not going to be in equilibrium. So for equilibrium, each and every object need to be satisfied both the condition. Okay. So one thing which you need to be know about it, that you have force. So the force is equal to F is equal to ma. So mass is not going to be zero because every object have a mass. So what will going to be zero? E. So it means acceleration is going to be zero in this condition because mass is not going to be zero. Object have a mass. So for a first condition, what is the procedure? That when for all sum of all the forces is going to be zero, it means that the acceleration is going to be zero. In a torque, then again it's inertia. Inertia is related to mass, so the inertia is always be there. Then alpha is the acceleration, angular acceleration, so it means the alpha is going to be zero. So in a torque, the angular acceleration is going to be zero. So it means that when sum of all the forces and sum of all the torque is equal to zero, then the object is going to be in equilibrium. So there's a choose an axis of rotation wisely to make a problem easier, but as long as you are consistent, everything will be okay. Okay, so this is two condition for equilibrium. So you study about torque, you study about equilibrium. So both are interrelated to each other, but so simple. We are going to be solve some of the example regarding torque and equilibrium, so you will be understand it better. So coming to one example, so you can be said multiple choice question. A meter stick is suspended at the center. If a 1 kg weight is placed at x is equal to 0, where do you need to place a 2 kg weight to balance it? So what does it mean now? He's saying that, like you can see here, that you have an object which have a mass m1 is equal to 1 kg, and you are replacing the mass m1 from axis of rotation to 50 meter. Okay, this is your fast. Then he's saying that they on the other side you are placing a 2 kg weight. So he's saying that where you are going to place this weight now, 2 kg. So when you find the distance or a displacement from the axis of rotation and the force, and this force is going to be equal, so it means the object is going to be in a equilibrium. So he's saying that the distance will be x is equal to 75. So I will solve it later on. Just keep in mind how it can be worked, so I will tell you later on. So coming to equilibrium again, so we have a two condition: force is equal to 0 all the force is going to be 0 and all the torque is going to be 0. So it means for all the forces the for all the forces acceleration is going to be 0 linear acceleration, and for all the torque the angular acceleration is going to be 0. So just example like, so we are saying that a rod is lying on the table. This is rod is lying on the table and has two equal forces. This is force, upward force and downward force. So two equal force but opposite forces in opposite direction. This direction is going to be in opposite. So the net force on the rod is, so if you can see, this force is counterclockwise or anti-clockwise. So this force is going to be positive. So and this force, so if this force is going to be positive, this force is going to be a negative, so the net force is going to be 0. So if the net force is going to be 0, it means the sum of all the forces is 0. Sum of all the force is 0. How you can say, like you can see this direction, this is in a clockwise and this is in a counterclockwise. So clockwise force is going to be positive, and the anti-clockwise force is going to be anti-clockwise force. This is anti-clockwise, this is going to be positive. This is clockwise force, this force is going to be negative. So plus minus f, so it's going to be 0. So it means the sum of all the force is going to be 0. What does it mean now? That this acceleration is going to be 0 now. So when this acceleration is going to be 0, it means forces is 0. This is the first condition. So now second condition, that you are applying this force and this force. So you can see this force is trying to rotate the object in this direction, and this want to be rotate the object in this direction. At the result, the object is going to be rotate. So it means there's a torque. So when there's a torque, so if you can see the rod has a no linear acceleration, so it wouldn't be translate. However, the rod will have a non-zero torque, hence a non-zero alpha. So mean you have an angular acceleration here because the object is going to be rotate. So it means the sum of all the torque is not going to be 0 now. So it means this object is not in a equilibrium because the object is rotating. So this is basically the concept behind the torque and equilibrium. So now coming to the review of a torque and equilibrium with including some example. So again the same definition, that when object going to be rotate, there is a torque, or you can say that the cross product of force and momentum is called torque. So again the same, this is, let's see, this is your axis of rotation, this is your origin, this is your momentum, and you are applying a force or upward or downward. So this will going to be rotate, so this is, there is a torque. So this is a perpendicular. I told you need to find a perpendicular component, so then you will going to be use sine theta. So how, so the perpendicular, so there is a theta of 90, so sine 90 is equal to 1, so you have a maximum torque. Okay, so the torque will be equal to T is equal to RF. So it's one thing, keep in mind, it's totally based on a game of angle. So when the angle is going to be 30, when it's going 45, 40, 50, 55, 60, 70, 90, 270, whatever, so the your torque is going to be changed. Even you will be face negative torque as well. Okay, again the unit of a torque is Newton meter. We studied that before as well, and counterclockwise rotation is always be positive. So this is an example. There's a torque example over there. So a person raises an angle so a person raises one leg to an angle of a 30 degree. Like this is a person, and this is going to be raise has legs up to 30 angle. So this is your angle now. Theta is open here. Okay, and so this is your basically this object is, the gravity is going to be applied on this object. So gravity wants to attract the leg downward. So this is the force now. Okay, so he said an ankle weight is 89 newton. So you have a force, this force is equal to 89 at a distance of 0.84 meters. So it means he's saying that this distance is 0.84 meter, okay, from her hip. What is the torque due to this weight? So he's saying that what will be the torque due to this force or due to this weight. So you know about T is equal to RF sine theta. You know about this formula. F R sine theta, RF sine theta doesn't matter. So you can be used that, because if you are watching again, here is the same perpendicular one. So this will be a 90. So 90 minus 30 will be 6. You can be used like this, and you can use like that R F sine 30. Because why we are saying that sine 30? Because this is the perpendicular component, so both are the same way. So now he said that if she raises, it's like another question, if she raises or if he raises her his leg higher, it means going to be move up, the torque due to the weight will be increase, same or decrease. So decrease, it's just I'm saying it's so wrong. So just what you can do, you just increase the theta. So the theta is 30, then 40. You can take it 40, because when the theta is going to be increased, it means it's a 30 now in this way. So if you want to be move up, so the theta is going to be changed. If you want to move up, the theta is going to be changed. So then you just you calculate it like for a 40 angle, or you can calculate it for a 50 or 60, then you know, and the torque is going to be increase or decrease. It's not a big deal. So you just make due to you make it on a calculator. So again, it's another example of the review of equilibrium. That he said that a rod is lying on a table and has two equal but opposite forces on it, acting on it. So you know about when we have a rod on the table, so we have a two forces: downward force and upward force. Downward force is due to gravity, and upward force is due to tension of the object. You know about the tension. Every object has their own resistance, their own tension force, which is always be in a upward direction. So downward direction is due to gravity, upward direction is due to tension. So two forces, F1 and F2. So downward direction, so if you take a downward direction is like a clockwise. So clockwise is going to be negative, and the upward force is going to be anti-clockwise, which is going to be positive. So positive and negative is going to be zero. So it means that what is the net force on the rod? We said it will be zero. But another question is, will the rod move? So the question is, will the rod move? So again, yes. Well, how you can know? Downward force wants to be rotate this object, and this want to be rotate this object. So at the end, it's going to be rotate. So this is called torque. So again, the review of equilibrium, condition for equilibrium. So we have a two condition: all the force is going to be zero and all the torque is going to be zero. For a forces, we will say that acceleration, linear acceleration is going to be zero, and for the torque, we will say that angular acceleration is going to be zero. Just for your review. So now the more important question, as you see in another lecture and another slide. So we will solve it here. He said that a meter stick is suspended at the center. This is a meter stick which is suspended at the center. If a 1 kg weight is placed at x is equal to 0, he said that this is the point is x is equal to 0. This is x is equal to 0. So we suspend a 1 kg weight at x is equal to 0. Where do you need to place a 2 kg weight? So where we want to place a 2 kg weight now? So find the distance now. So one thing which, okay, this was, he said it was a center. Okay, so in this question, this diagram will be available in your question. Okay, because I didn't write the date that a 1 kg will be placed at x is equal to 0 and the mid center and the total distance is 100 centimeters. So this will be available for you in the exam. So we are going to be find now that is this rod is going to, this stick is in equilibrium or not. So we need to be find it out. So 1 kg weight will be here and the 2 kg weight will be somewhere else where we need to find. So it means for equilibrium we can say that all the forces are going to be zero and all the torque is going to be zero. So so we are saying that okay, all the force is going to be zero, but especially now talking about the torque. So the sum of all the torque is going to be zero. So when all the torque is going to be zeros, and you have a formula that all the torque, so we can say that all the torque is zero. So we can say this is torque 1, maybe this is torque 2. So if you can say this torque, and this is going to be counterclockwise. How can counterclockwise? So it means it will be positive. So for a counterclockwise, we can say that T1, and this is clockwise, so it will be minus, so minus T2. So T1 minus T2 is equal to 0. So now T1 you know about RF, then again here the same formula RF. So we need to find a distance for 2 kg watt. So or you know about R here 50, and you have a, because you have a 1 kg weight, so this is weight, and weight is equal to W is equal to mg. And so I already told you that whenever the object is going to be down due to gravity, so the force is going to be changed to W is equal to mg. So you have a mass and you have a value of g, so 9.8. So 9.8 multiply with a 50 centimeters, so you can be converted to meter, so 50 will convert to 0.5 meter. Then minus R. So we don't know about R now. R we can use, we can say R or D, both are the same. And we know about the F. Again, this force, this object is going to be moved downward due to weight, and W is equal to mg. So W is equal to mg. So we know about m, which is 2 kg. We know about g, 9.8. So 9.8 multiply with 2, which is equal to 19.6, and d will be here. So just simply simplify the equation and you will have a d. So where we can where we can place a stick of a 2 kg, it will be on a d is equal to 25 meter. This will be in a meter. No, this will be in a centimeter. Okay, because this conversion. So this is the basically way how you can solve the question or numerical regarding equilibrium and torque. So this is another example. So you guys can be try it again, the same one. You have a F1, F2 and mg, three forces. Find the distance, find the force 1, F1, whatever. So all the torque and all the forces. Example of equilibrium. And this is your again summary. So hope you guys can find it well and have to be learned from the lecture. So anybody who have a question, so you guys can ask. So thank you for your time. See you in the next lecture.